functions having point of discontinuity in Fourier transformations. So in point of discontinuity, we can divide the given function into two subfunctions, phi of x and psi of x. So from the interval 0 to 2 pi, we will divide this interval into two parts, 0 to k and k to 2 pi. So f of x is phi of x. When x lies between 0 and k, it is psi of x when x lies between k and 2 pi. So our a naught value is like this. A naught is 1 by pi integral 0 to 2 pi f of x dx. This is 1 by pi. 0 to 2 pi can be splitted into two intervals, 0 to k phi of x plus pi to 2 pi psi of x dx. So likewise we will find an and bn values also. Now we will look at one example. Expand phi f of x is equal to 1, 0 less than x less than pi. It is 0 when x lies between pi and 2 pi. Okay, so expand this f of x as Fourier series. So we will take the given function. Now the Fourier series equation is f of x is equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos nx plus b n sin nx. So here a naught is 1 by pi integral 0 to pi f of x dx. Now we will divide this a naught function into two sub intervals. See here, this is 1 by pi integral 0 to pi 1 dx plus integral pi to 2 pi 0 dx. So this is 1 by pi. Why we are taking 1 and 0 here? So in our problem it is defined like this. 0 to pi it is 1, pi to 2 pi it is 0. So we are taking those values. So this is 1 by pi. Integral of 1 is x. X between the limits 0 and pi. Integral 0 is 0. So this is when we substitute pi, it is pi. When we substitute, it is 0. So it can be written as 1 by pi of pi minus 0. So this is equal to pi by pi, which is equal to 1. So a naught value is 1. Now we will find an value. An is 1 by pi integral 0 to 2 pi f of x cos nx dx. So this is 1 by pi integral 0 to pi. Split this interval 0 to 2 pi as 0 to pi and pi to 2 pi. So 0 to pi f of x cos nx plus pi to 2 pi f of x cos nx dx. So 1 by pi integral 0 to pi f of x cos nx is f of x is 1 here. So 1 into cos nx. Here f of x is 0. So this whole term is 0. Now 1 into cos nx. Cos nx. So this is equal to an is 0 because integral 0 to pi cos nx is 0. So an value is 0. Now bn. 1 by pi integral 0 to pi f of x sin nx dx. Again split the interval as 0 to pi, pi to 2 pi f of x sin nx dx. Now 1 by pi integral 0 to pi. Here it is 1, here it is f of x is 0. So 1 into sin nx is this sin nx. Now if we take the 1 by pi, integral sin nx is minus cos nx by n between the limits 0 and pi. Now if we substitute the limits, minus 1 by n pi cos n pi minus cos 0. So this is minus 1 by n pi. Cos n pi value is minus 1 to the power of n. Minus cos 0 is 1. So if n is even, if we take n as even number, if we take it is 1, minus 1 by pi minus 1 whole, if you take n is 2, this is minus 1 by 2 pi, minus 1 whole square is plus 1, plus 1 minus 1 0. So if n is even, this whole term is 0. If n is odd, this is 2 by n pi. So that is the bn value. Bn is 2 by 2n minus 1 pi in general odd method. So the required Fourier series is f of x is a naught is 1, a n is 0 and b n is 2 by 2n minus pi by pi. So f of x is equal to a naught by 2, a naught is 1 by 2 plus sigma n equal to 1 to infinity 2 by 2n minus 1 into pi sin nx.